For the speed of sound experiment, we produced resonance in an open tube partially filled with water to determine the speed of sound at 0 degrees Celsius. First, we needed to determine the temperature of an environment. Because we do not have access to thermometers, we use physics and chemistry principles to determine the temperature both inside and outside the house. By measuring volume, number of moles of gas, and pressure, we can derive temperature using the ideal gas law. To measure length, we made a ruler using kinematics. If we're dropping an object from rest, v naught t equals 0. Since we know gravity, we can determine the height from which we dropped an object by timing its descent. We timed the fall using a 5-fox acoustic stopwatch and then found that displacement equals 2 meters. We then used a piece of string to record the distance the mass fell. After folding the string into halves and fifths, we obtained a 20 centimeter, 10 centimeter, and 1 centimeter length string for the experiment. In order to measure volume, we obtained cylindrical shaped containers and used our makeshift rulers to measure the dimensions. By wrapping a piece of string around the container and comparing them with their string segments to measure circumference, we were able to find R. Using the strings, we can measure the height of the liquid in the container and calculate volume. To measure the moles of gas, we use a reaction between baking soda and vinegar. As baking soda will be the limiting reagent, we don't need to measure acetic acid. We can determine the mass of baking soda by comparing with water. Knowing density of water, 5 grams, is equivalent to 5 milliliters, so we pour the water using volume calculations as mentioned before, and use a balance scale to weigh out 5 grams of baking soda. From here, we use a molar mass of baking soda and divide the mass by the molar mass to determine the number of moles. We use a 5-fox barometer to measure the pressure both inside and outside the room. Lastly, we know the value of the ideal gas constant, R. Now to find temperature, we fill the balloon with the CO2 produced by the baking soda and vinegar reaction. After leaving the balloon environment for around 10 minutes, we measure its different volumes by submerging it into a tank completely filled with water and measure the water displaced, which is equivalent to the volume of the balloon. Now that we know all the variables, all we need to do is rearrange the ideal gas law to find temperature. With temperatures at 2 different locations, we can calculate their speed of sound. We filled a graduated cylinder with water and left it at the 2 environments for approximately 1 hour for the temperature to be about the same as the surroundings. To conduct this experiment, we obtained 3 tuning forks in which we determined this frequency using a 5-fox frequency history function. We put the tuning fork at the opening of the tube inside the graduated cylinder and lifted the tube until we heard the resonance. We then used a string to measure the distance from the water level to the opening of the tube and record our results. We measured the wavelength at 3 different resonant lengths. We rearranged the fraction of lambda and then used v equals lambda f to find the speed of sound. We did this calculation for all 3 tuning forks in both temperatures and determined the speed of sound for all of them. We used a 1.5 times IQR rule to find outliers in our data and found no outliers. Using a Google-Sheets lines function, we found the y-intercept of the speed of sound versus temperature scatter plot. We then made sure our data fulfilled the necessary conditions and conducted 90% theta interval for the y-intercepts, giving us a point estimate for the speed of sound at 0 degrees Celsius and a margin of error. To calculate the critical t-value, we used a Google-Sheets t-interval function, took the critical t-value and multiplied by the standard error of the y-intercept to get our margin of error. Our final estimate for the speed of sound at 0 degrees is 324 meters per second plus or minus 4.97. To 3 sig figs, we are 90% confident that the interval from 319 to 329 meters per second captures the true value of speed of sound at 0 degrees Celsius. We hypothesized the source of the error may come from balloon leaking over time, baking soda not fully reacting with vinegar, inaccuracy of string, and inaccuracy of resin lengths.